And welcome back to Mr. Gregoris Math. Today we're taking a look at finding the location of a vertex, and we're going to do it using factored form. So factored form allows us to determine the value of the roots. To get to factored form, we need to start something that's in standard form, and we need to factor it. So I'm going to go ahead and factor the right-hand side of this. So I know that this is a simple trinomial, so it's going to have x terms in the front. The sides are going to be negative and the same because of my sine rule. Now I'm looking for the factors of 5 that make 6. So 5 is a nice simple prime number. The only numbers it can be are 1 and 5, and 1 and 5 do indeed make 6. So that is the quadratic in factored form. X minus 5, x minus 1. Furthermore, in factored form, this tells me that my roots are at 5 and 1. Just remember, it's the opposite sign, because what you're actually finding is, hey, when x minus 5 equals 0, what value of x solves this? We would add 5 to both sides to get x alone, and we would get x is equal to 5, which is why there's a root at 5. Similarly, you can find that there's a root at 1. Now, because I know my roots are at 1 and 5, and because I know that quadratics are symmetrical, I can go ahead and sketch on my axis of symmetry. It goes right down the middle. Now, going right down the middle means it has an equation of x equals, and this is important, you add your two roots. So those are r plus s. The values of r and s are the values of your roots. So this is going to be 1 plus 5 divided by 2. And again, what we're really just doing here is finding the midpoint. And so that's 3. So we know the x-coordinate of my vertex here is at 3. And the equation of my axis of symmetry is the line x equals 3. Remember, those are vertical lines. So now, to find the y-coordinate, I'm going to go back into my y of my equation, and I'm going to substitute x equals 3. Now what that looks like, and I could pick either this equation or this equation, it'll be the same result. I'm going to pick the factored form, though, because I think it might be easier for me to do. So this will be 3 minus 5 times 3 minus 1. Now, 3 minus 5 is negative 2, and 3 minus 1 is positive 2, and negative 2 times positive 2 is negative 4. So that is where my vertex is. It's at x equals 3, y equals negative 4. The vertex is at 3, negative 4. That's how to find a vertex from standard form with factoring. So here we use symmetry. Key idea was this formula for the vertex's x-coordinate, and then substituting back in to find our value of y. Don't forget to hit like, subscribe, and ring that notification bell so that when new content drops, you can be the first to be up to date with your new fantabulous factoring work. Take good care. And as always, factoring is a religion.